Hi everyone, welcome to my new video in my Mathematics Essentials series. In this video, I will discuss the graph of one of our reciprocal trigonometric functions. This one will be y equals the cosecant of theta. Okay, so in the previous video, I introduced the reciprocal trigonometric functions cosecant, secant, and cotangent. In this video, I'm graphing y equals cosecant of theta. So let's start by putting down an theta y-axis. Okay, so here's the theta axis, here's the y-axis. Okay, let's put some theta values down on the graph. So let's say this is 2 pi, halfway, negative pi, and pi. That will be that will be positive pi on 2. This will be negative pi on 2. This will be negative 3 pi on 2. And this will be positive pi on 2. Okay, well, let's start with finding theta intercepts, if there are any. And to find theta intercepts, we would set y equal to 0. Theta intercepts. Okay, well, for theta intercepts, we would set y equal to 0. So let's let y equal to 0, but y is just equal to the cosecant of theta. That's what we're graphing, y equals the cosecant of theta. So setting y equal to 0 is like setting the cosecant of theta equal to 0, but the cosecant of theta is just 1 over the sine of theta equal to 0. And there's no way to get 0 out of this quotient here on the left-hand side. So if you've got a quotient or a fraction, let's say a over b, the only way that this could equal 0 is if the numerator equals 0. Okay, the denominator can't equal 0 because division by 0 is undefined. And in our case, the numerator isn't 0, it's 1. So there's no way this could actually give us 0. And to see this perhaps more clearly, look what happens if we multiply both sides by sine of theta to get rid of the fraction on the left-hand side. We would be multiplying by sine of theta on the left-hand side. So sine of theta times 1 over the sine of theta. And on the right-hand side, we would be multiplying 0 by the sine of theta, which we don't need to write because it won't really do anything. It will just be 0. But these sines of theta would cancel, and we would be left with 1 equals 0, okay, which we know is false because we know 1 does not equal 0. So these two statements together imply a contradiction, all right? And whenever you get a contradiction, you have to find someone to blame. Someone must pay, okay? So who's the culprit? Turns out this is the assumption that generated the contradiction down here. Okay, the contradiction down here. Okay, so the assumption that y could take the value 0 made us say something silly. So we need to punish y for embarrassing us, and we do that by saying, y, you can't do that. You can't be 0. All right, that's what you get. If you're gonna make us look silly, you can't do whatever the hell you want. Okay, but more precisely, if y taking the value 0 leads to a contradiction. So it's impossible that y takes the value 0 in this function. All right. So if y can't take the value 0, that means there aren't going to be any theta intercepts. So that might be cause for despair because intercepts are typically some information that we plot on a graph to help us graph the function. So we're going to have to make do without theta intercepts, but maybe we can get some y-intercepts. Maybe they can help us graph the function. So let's consider y-intercepts. Y-intercepts? Question mark? Like, please be some y-intercepts. Please make my time easier. I don't know what I'm going to do if there aren't any y-intercepts. Okay, to find y-intercepts, we're going to have to set theta equal to 0, okay, because that's the value for theta for which the graph could intercept the y-axis, right? Now, in other words, the y-axis is just the vertical line theta equals 0. So if we set theta equal to 0, then our function y equals the cosecant of theta is just y equals the cosecant of 0 because we set theta equal to 0, okay? But cosecant is just 1 over the sine of 0. And the sine of 0 is 0, okay? You can see this from a unit circle. I'm going to place one down because we might need one later. Come into existence. I summon you. All right, so I just summoned a unit circle. And you can see on the unit circle that sine of 0 is 0. This angle between that point on the circumference of the unit circle, okay, or the angle between the line I've drawn to that point and the x-axis is 0, because the line I drew just is on the x-axis. So the angle there is 0, and the sine of that angle would be 0. So sine of 0 is just 0, but that means we'd be dividing by 0. We'd have 1 over 0. But this is undefined. Okay, it doesn't make sense. Can't divide by 0. So what made us divide by 0? We've got to blame someone for this. Whenever we do something silly, we've got to blame someone. It can't be us. It's got to be someone else. And it's this theta guy up here. Okay? We're not silly. Alright, theta thinking that it can take the value 0 is silly. Okay? So turns out theta can't be 0. And if theta can't be 0, well, our function's not going to have y-intercepts. So we're going to have to make do without y-intercepts and theta-intercepts. Okay. Well, lucky for us, our attempt to find y-intercepts did reveal something helpful, that there are parts of the graph that are undefined, which means there are theta values which make the function undefined. So we've already got one, and that is when theta equals 0. And if we know that the function is undefined at theta equals 0, we are justified in placing an asymptote down at theta equals 0. And theta equals 0 is just the y-axis. Okay, so I'm going to place an asymptote down. I'll do it in white so you can see it over the gray, which I did the axis in. So here's vertical dashed line. Okay, to indicate that theta equals 0, in other words, the y-axis is an asymptote. But, what else do you know about when sine of theta equals 0? You may recall from a previous video that, okay, whenever theta is any integer multiple of pi, sine of theta will be undefined. Okay, you can see that from the unit circle. If you imagine heading around the unit circle in an anti-clockwise direction from the positive x-axis, you can see that anytime you hit pi radians, okay, or some even multiple of pi, you're going to get these sine of theta values equal to 0. Okay, so maybe you remember I expressed it like this. Okay, for theta equals n pi, okay, sine of theta, which would just be sine of n pi, will equal 0, right? Where n's just some integer. Okay, so that means for every integer multiple of pi, we know that sine of theta would be equal to 0, and if sine of theta is equal to 0, we're going to get this problem here, division by 0, which is undefined. So every integer multiple of pi needs an asymptote. Okay, so we can put these asymptotes down at any n pi, any integer multiple of pi. So we'll put one down at pi, we'll put one down at 2 pi, and let's not neglect the negative integers. They need asymptotes too, okay, because the graph of the function will be undefined there as well. So the last asymptote we'll put down is at negative 2 pi, because that's as far as my axis extends in the negative theta direction. Okay, well, we can't make do with intercepts, but we do have asymptotes, all right? And if we have asymptotes, we know that our graph is going to have to display asymptotic behavior, which means the graph is going to have to head towards these asymptotes. So this reveals more than it may seem at first. Consider this. Let's suppose the graph has some point here above the theta axis. Well, then we know that from this point, when the graph comes through this point, okay, it has to head towards this asymptote. All right, well, is it going to head down towards the asymptote? Or is it going to approach the asymptote by heading upwards? By decreasing in y values or by increasing in y values? It has to approach the asymptote, we know that much. So the only question is up or down. Well, notice that if we were to head down, eventually we would have to cross the theta axis. And we know that we can't cross the theta axis because there are no theta intercepts. We found that out when y, that pesky y variable, made us say something silly. Okay. All right. So we can't cross the theta axis, but we need to approach the asymptote. So that means we can't approach the asymptote by heading down. We have to be heading up. Okay. So if the graph had some point where I've put down that red dot, if it was to approach the asymptote, it must be heading up. Okay, it must be trending upwards to approach that asymptote. Now, let's imagine it was down here. All right, we know that it has to approach this asymptote, and it has to approach this asymptote. Okay, how's it going to do that? Well, if it was to trend upwards, to keep approaching the asymptote, it's eventually going to have to cross the theta axis. We know we can't do that. Similarly, for approaching the other asymptote at pi, if it was to trend upwards, it would have to cross the theta axis. We know that no crossing of the theta axis is permissible. We know the graph won't do that, okay? Because that would break math. We'd have to say things like one is equal to 0. So, if there's some point here or anywhere, it's going to have to approach the asymptotes by heading down, okay, to avoid crossing the theta axis, which means we just need to find a point. Well, first we need to find out whether, which parts of the graph are above and below the theta axis, and we can do that by splitting the theta axis up into intervals. So we can consider like the interval from theta equals 0 to pi on 2, from pi on 2 to pi, not inclusive, and we can just determine whether the graph has a point above or below the theta axis in that interval. And once we know, for instance, that it's above, we know that it has to stay above, right? It has to head towards the asymptotes either side of it and stay above the theta axis because it can't cross. Similarly, for if we found out that it was below, okay, then it has to stay below, all right? There might be parts of the graph that are above and below, all right, but there will be no crossing of the theta axis. Nothing of that sort will occur, right? So, two things will help us do this: to find some points and determine whether the graph is positive or negative. They almost come down to the same thing. So let's consider some intervals. Let's talk about this one here between theta equals 0 and pi on 2. Is the graph positive or negative there? All right. In other words, the y values, are they positive or negative? Is the graph above or below the theta axis is another way to ask that question. We can double the role of this unit circle as a cast diagram. Okay, let's make it earn its money. Just been sitting here doing nothing for a while. Lazy unit circle. Now remember, this cast diagram tells us where our trigonometric functions are positive and consequently also where they are negative. We could make this a cast diagram just for cosecant of theta. So y equals the cosecant of theta is just 1 over the sine of theta. Okay, and from this it follows that wherever sine of theta is positive, cosecant of theta will be positive, and wherever sine of theta is negative, cosecant of theta will be negative. Okay, and you can see that up here, sine is positive in both of those quadrants, so between 0 and pi, okay, and down here, sine of theta is negative in both of those quadrants. Okay, so in other words, we can just say that for cosecant of theta, we can say it's positive here, and it's negative here, and here. And now let's consider these intervals. So let's consider like from 0 to pi on 2. 0 non-inclusive, because that would make the function undefined. Okay, let's go from 0 to pi on 2. We know that it's positive. Okay, and from pi on 2 to pi, non-inclusive, we know it's positive. Okay, so we can just put like a like an asterisk or something here to say it's positive in that interval and to say it's positive in that interval. And you know what? Our cast diagram tells us that in the interval from pi to 3 pi on 2, it's negative. So we can put an asterisk down here. And from the interval, the interval from 3 pi on 2 to 2 pi, which is this one, it's negative as well. So we can put an asterisk down here. Okay. Now, if we headed in the other direction, that would just correspond to negative angles, negative values of theta. Okay, what our cast diagram tells us isn't going to change. All right, it's not as if like these negative signs would become positive signs or vice versa. That's not going to happen. Okay, so when we head in the opposite direction, let's say from 0 to negative pi on 2, we're going to have the graph below the theta axis. Okay, and the cast diagram tells us that from negative pi on 2 to negative pi, we're going to have negative values, or the graph will be below the theta axis, and then it tells us that we get positive in the next quadrant and positive in the quadrant after that. So in this interval we're going to be positive, and then in this interval we're going to be positive again, which means, let's say we have some point here, the graph is going to have to head towards that asymptote and that asymptote by trending upwards. If we have some point on the graph here, we know that it's going to have to head towards that asymptote and that asymptote by trending downwards. If it's here, it's going to head towards that asymptote and that asymptote by trending upwards. You get the idea. Okay, so now what I'll do is I will graph the function. I'll pick green. Okay, and it's going to be handy if we can have some points first to consider. So let's try and come up with some simple points. And since the cosecant of theta is just 1 over the sine of theta, all right, some simple points to consider are just whenever the cosecant, whenever sine of theta equals 1 or -1, because then we're just going to have, cosecant of theta equals 1 over -1, or cosecant of theta equals 1 over 1, okay, and both of these will just equal either 1 or -1, okay, that will be nice. So sine of theta equals 1 here, and sine of theta equals -1 here, so whenever values of theta get us there, okay, and multiples of those values of theta, which will get us back there, we're going to have 1 and -1. We're going to have cosec of theta equal to 1 and -1, okay, and you can see that these are just values of pi over 2, but the odd values. So you can see, odd multiples, I should say. So let's put in some y values, okay, and reset. That's green. Let's stick to color consistency. Let's stick to gray for color consistency. So let's put in a y equals +1 here and a y equals -1 here. Okay, and we can see that we're going to have a point on the graph at theta equals pi on 2 and y equals 1. Okay, when theta equals pi on 2, sine of theta is going to equal 1. Okay, so the cosecant of theta would equal 1 over 1, which would give us 1. That's what the y value would be. Okay, and we also saw that at 3 pi over 2, we're going to have, I'll put these points in green because that's what I intend to draw the function in. Okay, we're going to have a point on the graph at theta equals 3 pi on 2 and y equals -1. So then by symmetry, if we were to head in the opposite direction, we would have a point at theta equals -pi on 2 and y equals -1, and then we would have a point on the graph at theta equals -3 pi on 2 and y equals 1. And look, this corresponds to where we drew our asterisks, so we're not getting any contrary information to what we expected here. So now we can graph the function. Like, I think we have enough information now, and we didn't even need intercepts. Okay, so let's do it. How do I do that one so straight? How do I draw that line so straight? Did I use a ruler for that? I couldn't do that. That one's like wonky. That's weird. Maybe I was in a worse mood when I drew that line, so I drew it with more like aggressive commitment. I was like chill and happy when I drew that one. I blame Y. Remember how Y made me say something silly? Okay, Y made me say something silly like this, which even you know isn't true. That's probably why that one is straight. I was upset with Y because I saw it again. Anyways, let's do this. Okay. Let's start from this point and just approach the asymptote. We know we have to trend upwards because if we were to trend downwards towards the asymptote at pi, we would cross the theta axis, which we know we can't do. Okay, the theta axis and the y-axis are like barbed wire fences. Okay, they will hurt you. They will hurt your mathematics grade in an exam when you cross them. All right, let's trend towards this asymptote at the y-axis, theta equals 0. Okay, right, and let's start at this point here. We know that we have to trend towards this asymptote at pi. We can never touch it, so we have to display some asymptotic behavior. We have to trend downwards towards this one at 2 pi. We could trend upwards because we'd have to cross the theta axis to keep approaching the asymptote at 2 pi. We can't cross the theta axis. Okay, and for similar reasoning, this is going to happen. We have to approach that asymptote. We have to approach this asymptote. Okay, we can't approach them by trending upwards because we cross the theta axis, which we know we can't do. And then we're going to see this kind of behavior. So really, what was the clue? It was that in the end, there were several clues, but in the end, the fact that there were no theta intercepts and that there were no y-intercepts actually helped us graph the function, okay? Intercepts help us graph the function, but knowing that they don't exist also help us graph the function too, okay? We knew that we couldn't cross them, and that's what enabled us to determine that these curves on the graph of y equals the cosecant of theta must trend upwards towards asymptotes rather than downwards, because to approach the asymptote, you would cross the theta axis, and for these ones, vice versa, they must trend downwards as they approach the asymptotes either side, because if they were to approach the asymptotes by trending upwards, they would cross the theta axis, which we know the graph doesn't do. Okay? Of course, this reasoning wouldn't be possible if we didn't know that there were asymptotes to begin with. All right, and our first clue about there being asymptotes was the fact that y equals the cosecant of theta is a reciprocal function, which implies that it's a quotient. You know, it's a fraction, and whenever you have a fraction, you're going to have values where the graph just isn't defined. Anything that makes you divide by 0 is going to be undefined. Okay, so I hope you found this video helpful. If you did, feel free to give it a like, feel free to share it with your friends. If you would like a notification when I upload a new video, subscribe to my channel. In the next video, I will graph the function y equals the secant of theta. Okay, and if anything was confusing, don't hesitate to ask a question in the comments. Okay, until next time, bye for now.